Hello, welcome to the channel. In this video, I'll be discussing the M.Sc entrance exam questions which had appeared in KUD M.Sc entrance examination 2021, and I'll be taking the questions from inorganic section, that is question number 1 to question number 17. The first question, so what they have asked in this question is regarding the conjugate acid-base pairs, and they have given the reaction, one reaction kottidare, and based on this reaction you have to identify the conjugate acid-base pairs. In fact, conjugate acid-base pairs andre enu anta gottididre this question it will be very simple. First we should know this fact that conjugate acid-base pairs are acid-base pairs which differ by a single proton. So pair of species, they will be differing by just a proton, single proton. So such species we can call them as conjugate acid base pair, and e reaction alli conjugate acid base pair yaudu adanna identify madlikke kelidare, right? So if I look at this reaction, what I can find here is that it is HSO4 minus ion, it is hydrogen sulfate or bisulfate ion, right? So this is reacting with hydroxide ion, and we can clearly see that this is transferring a proton to this species. Illinda illi one proton transfer aagta ide, and therefore this is acting as acid, and this is accepting the proton, so therefore this is acting as base in the forward reaction. So now ನೀವು backward reaction ನೋಡ್ತೀರಿ ಅಂತ ಹೇಳಿದ್ರೆ, in the backward reaction, if you assume that the reaction it proceeds in backward way, ಅವಾಗ ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ from this H2O species, OH minus, after accepting proton it has been converted into H2O. So this will be transferring a proton to this sulfate ion. Reverse reaction ಆಗುತ್ತೆ ಅಂತ ತಿಳ್ಕೊಂಡ್ರೆ. So therefore in the reverse reaction this H2O it is proton donor, so therefore this will be acid, and sulfate ion it is accepting the proton, so therefore it will be base in the reverse reaction. Now if you consider these two species, HSO4 minus species and SO42 minus species, so this is acid and this is base, and it is a acid base pair which is just differing by a proton. Illi one proton ಜಾಸ್ತಿ ಇದೆ, ಇಲ್ಲಿ ಒಂದು proton ಕಡಿಮೆ ಇದೆ. Similarly hydroxide ion and water, if you look at, so this is base and this is acid, so ಇದು ಒಂದು acid base pair, they are differing by just a single proton, and therefore this is one more conjugate acid base pair. So ಹಾಗಾಗಿ HSO4 minus and sulfate ion, and hydroxide ion and H2O ion. So that is this first option, HSO4 minus and SO42 minus ion, and H2O and OH minus ion. So this will be the correct answer for the question. So very simple question, and we can expect similar questions in the upcoming examinations too. Right. The second question, what they have asked here is to calculate the sigma. Sigma is screening constant for 4s electron of potassium, they have asked, and to calculate that, right, first we need to know what are Slater's rules. Based on Slater's rules calculate ಮಾಡ್ರಿ ಅಂತ ಕೇಳ್ಬಿಟ್ಟಿದ್ದಾರೆ. So what are Slater's rules? Brief ಆಗಿ next slide ಅಲ್ಲಿ ಕೊಟ್ಟಿದ್ದೇನೆ, so you can just pause the video and you can just go through those Slater's rules, and ಬೇರೆ systems ಗೆ ಬೇರೆ electrons ಗೆ calculate ಮಾಡಬೇಕಾದ್ರೆ Slater's rules ಹೇಗೆ apply ಆಗುತ್ತೆ ಅನ್ನೋದನ್ನ you need to practice, and we can expect repeatedly questions related to this calculation of Z effective as well as calculation of screening constant sigma. So coming to this question, potassium electronic configuration ಬರ್ಕೊಂಡಿದ್ದೀನಿ, 1s2, 2s2 2p6, 3s2 3p6 and 4s1. This is the electronic configuration, and according to Slater's rules these electrons they are grouped. So 4s electronic calculate ಮಾಡ್ಕೊಳ್ತಾ ಇದ್ದೀನಿ, ಅದನ್ನ ಬಿಟ್ಟು so ಅದರದ್ದು previous group I have called it as n-1. Remember, so here ಇದು n-1, n-2, n-3 ಅನ್ನೋದು it is not with respect to normal electronic configuration. Slater's rules ಪ್ರಕಾರ ಅದನ್ನ ಕ್ಲಾಸಿಫೈ ಮಾಡ್ಕೊಂಡಾಗ accordingly n-1, n-2, n-3 ಆ ತರದ್ದು grouping name ಕೊಡ್ತಾ ಹೋಗ್ತೇವೆ. So it is this. So now once it is done, ಈ ತರ s ಮತ್ತೆ p electrons ಅನ್ನ ಒಂದೊಂದು ಗ್ರೂಪ್ ಮಾಡ್ಕೋತಾ ಹೋಗಬೇಕು according to the rules, right? So ಯಾವುದಕ್ಕೆ observe ಮಾಡ್ತಾ ಇದ್ದೇವೆ, so that will not be contributing anything to the screening constant, so therefore contribution from this 4s electron it will not be there, and next ಅದಕ್ಕಿಂತ previous ಇರುವಂತದ್ದು ಎಲ್ಲದು contribute ಮಾಡುತ್ತೆ. So this is n-1. If you are observing a s electron according to Slater's rules, for s electron n-1 electrons, n-1 electrons they will be contributing 0.85, so 8 electrons, 0.85 into 8. All other electrons they will be contributing 1, right? So for a s electron except n-1, all other electrons they will be contributing 1 according to the Slater's rules. So therefore this will be 10 electrons totally, here 8 and here totally 10 electrons, 10 into 1.0. And see here, it is not necessary to simplify this. Exactly sigma ಎಷ್ಟಾಗುತ್ತೆ ಅಂತ ಹೇಳಿ 10 into 1 is 10 and then 0.85 into 8 ಮಾಡ್ಕೊಂಡು ಸಮ್ ಮಾಡುವಂತ ನೆಸೆಸಿಟಿ ಇಲ್ಲ. ಆಲ್ವೇಸ್ ಯು ಶುಡ್ ಹ್ಯಾವ್ ಎ ಲುಕ್ ಎಟ್ ದ ಆಪ್ಷನ್ಸ್. ಸೊ ಜಸ್ಟ್ ಹೇಗೆ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ತೀರಿ ಅನ್ನೋದನ್ನ ಕೇಳಿದ್ದಾರೆ. ಅಂಡ್ ಸಿ ಫಸ್ಟ್ ಪಾರ್ಟ್ ಎವ್ರಿವೇರ್ 8 ದಿಂದಾನೆ ಸ್ಟಾರ್ಟ್ ಮಾಡಿದ್ದಾರೆ ಟು ಕನ್ಫ್ಯೂಸ್ ಯು. ಸೊ ಕರೆಕ್ಟ್ಲಿ ನಿಮ್ ಸ್ಲೇಟರ್ಸ್ ರೂಲ್ಸ್ ಗೊತ್ತಿದ್ರೆ ಯು ಕ್ಯಾನ್ ಜಸ್ಟ್ ಸೇ ದಟ್ ಇಟ್ ಶುಡ್ ಬಿ ಲೈಕ್ 10 into 1.0 here you can find that, and 0.85 into 8 that can be found here, and that's how option A for this question also. Option A it should be the correct answer. Right? See, one step ahead they can go. So once you calculate this sigma, what is known as screening constant, from that it is possible to calculate Z effective. So Z effective it will be Z minus sigma. Idu sigma simplify ಮಾಡ್ಕೊಂಡು ಎಷ್ಟಾಗುತ್ತೆ ಅಂತ ನೋಡ್ಕೊಳ್ಬೇಕು. Z for potassium it is well known 19 minus screening constant ಮಾಡಿದ್ರೆ effective nuclear charge on the outermost electron of potassium it can be calculated, right? So if you just go one step ahead, you can answer questions related to calculation of Z effective also. Let me go to the next question. So yeah, before I go to the next question, Slater's rules, as I told you, Slater's rules has been summarized here. You can just pause the video and you can just memorize these rules as they are very, very important. So yeah, the next question. The total number of bond pairs and lone pair electrons in H2SO4. H2SO4 molecule ಅಲ್ಲಿ total ಎಷ್ಟು lone pairs ಇರುತ್ತೆ, ಎಷ್ಟು bonded pairs ಇರುತ್ತೆ ಅಂತ ಕೇಳಿದ್ದಾರೆ. If you know the proper Lewis structure of H2SO4, this is damn simple question. You need to just calculate the bond pairs as well as lone pairs, right? Readily I have written the Lewis structure of H2SO4 sulfuric acid, right? Now you can easily count the total number of bond pairs as well as lone pairs. First, if I count the lone pairs, each oxygen atom it has 2 lone pairs, right? And 4 oxygen atoms are present. Each oxygen atom it has 2 lone pairs as represented here. So totally 8 lone pairs should be present. Hydrogen ಮೇಲೆ lone pairs ಇರೋದಿಲ್ಲ. And sulfur ಅದು ಅದರದ್ದು highest valency ತೋರಿಸ್ತಾ ಇದೆ. Valency of sulfur in this case it is 6, and therefore no lone pairs are left over sulfur. So total number of lone pairs it will be 8. And bonded pairs count ಮಾಡಿದ್ರೆ here you can find one bond. This is one bonded pair, second bonded pair, third bonded pair, and fourth bonded pair. And double bond ಇರೋದ್ರಿಂದ you should count this SO double bond ಅನ್ನ ಎರಡೆರಡು ತಗೊಳ್ಬೇಕು. So like totally here there were 4, 5, 6, 7, 8. So lone pairs it will be 8, and bond pairs that will also be 8. And you can find that option here, option B, which is 8 and 8. So therefore correct answer for this question it will be option B, 8 and 8. Right? So Lewis structure ಗೊತ್ತಿದೆ ಅಂತ ಹೇಳಿದ್ರೆ easily this question it can be written. So the thing is, if this kind of questions are asked, you should know how to write the appropriate Lewis structure of the given compound. Fourth question, very, very important one because it is based on a very, very important concept called as VSEPR. And for any examination, chemistry exam ಇದೆ ಅಂತ ಹೇಳಂದ್ರೆ competitive exam, you can expect minimum one question related to VSEPR. And if you have mastered this VSEPR, definitely you can answer any questions related to this VSEPR, right? So you can find the VSEPR related separate video in the channel. You can just go through that if you are new to VSEPR. So straight away, if I apply VSEPR theory to this species ICl4-, how I can deduce the shape as well as geometry of this particular molecule, that we shall see now, right? So the given species it is ICl4-. So central atom we need to identify first. Central atom yavudirutte anta helindre least electronegative atom, usually it will be the central atom. So here I and Cl tagondaga iodine being less electronegative, that you can consider it to be the least electronegative atom. So that will be central atom, so I, right? And we should know the outer electronic configuration of I it is halogen ಅಂತ ಹೇಳಿದ್ರೆ in halogen we can have totally 7 outer electrons. And what I do is, there is one more extra charge here, as you can find here, ICl4- ಅಂತ ಇದೆ. So one extra electron is there. So that extra electron ಅದನ್ನ ಯಾವ ಮೊಮೆಂಟ್ ಅಲ್ಲೂ ಆಡ್ ಮಾಡಬಹುದು. I shall take it now itself. So I am adding it to the central atom, right? So this is total I and one minus charge that I have covered. Now what I need to do is, I need to take care of these Cl atoms. Each Cl, remember always for the central atom, ಅದರದ್ದು valence shell ಅಲ್ಲಿ ಎಷ್ಟು electrons ಇದೆ ಅಷ್ಟನ್ನು ತಗೊಳ್ತೇವೆ. The other atoms, usually these are called as ligands. So ಅದಕ್ಕೆ unpaired electrons ಎಷ್ಟಿದೆ ಅಷ್ಟು ಮಾತ್ರ ಕನ್ಸಿಡರ್ ಮಾಡ್ಕೊಳ್ತೇವೆ. Cl it is also halogen. It also has 7 electrons, but according to VSEPR, it is acting as ligand, and you can just say that it is having just one unpaired electron. That one unpaired electron, if I consider for Cl, that would be sufficient. Each Cl, it is coming with one unpaired electron. And to make bond with iodine, right, 4 Cl ಬರ್ತಾ ಇದೆ ಅಂತ ಹೇಳಿದ್ರೆ what we need to have is 4 unpaired electrons over this I. So what I do is, just for convenience, I'll just unpair these electrons. So paired electrons, whatever I have shown. So let me just unpair them. Let's say I just write them a little far away, right? So now easily we can say that each Cl atom, it will come. This is the electron which is coming from Cl. So each Cl, it is coming with one unpaired electron, and it is making bond with the iodine atom. So now the same thing I can represent in this way, in a different way if I represent. So electrons from dots, I just replace them with lines. Say 4 chlorine atoms, they are making 4 bonds with iodine, and 2 lone pairs, as you can see here, 2 lone pairs, here one and here one. So those are left over iodine atoms. So therefore I just represent them like this, right? So this is not bond, exactly bond, just to represent the lone pairs, have taken the line, right? So now this is the overall picture according to VSEPR. So now what we can do is, now we can just count the total number of lone pairs as well as total number of bond pairs over this. So now as you can find, 2 lone pairs ಕಾಣ್ತಾ ಇದೆ, 4 bonded pairs ಕಾಣ್ತಾ ಇದೆ. Bond pairs, it will be 4, and lone pairs, it will be 2. According to VSEPR, lone pairs and bond pairs, if they are summed together, that is called as steric number, and 4 plus 2, it will come to 6. And based on this steric number, directly you can decide the geometry, right? So lone pairs ಮತ್ತೆ ಬಾಂಡ್ ಪೇರ್ಸ್ ಅನ್ನು ಕೂಡಿಸಿದಾಗ ಏನ್ ಬರುತ್ತೆ, ಸೊ ಈ ನಂಬರ್ ಬೇಸ್ ಮೇಲೆ ಸ್ಟ್ರೇಟ್ ಅವೇ VSEPR ಏನ್ ಜೊಮೆಟ್ರಿ ಬರುತ್ತೆ ಅಂತ ಕೊಡುತ್ತೆ. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ 2 ಇದ್ರೆ ಲೀನಿಯರ್, ಅಂಡ್ 3 ಇದ್ರೆ ಟ್ರಯಾಂಗ್ಯುಲರ್ ಪ್ಲೇನಾರ್, 4 ಇದ್ರೆ ಟೆಟ್ರಾಹೆಡ್ರಲ್, ಅಂಡ್ ಫಾರ್ 6 it is octahedral. So therefore geometry, it is octahedral. Remember, geometry ಅಂತ ಕೇಳಿದಾಗ even you should consider these lone pairs. A lone pairs kuda position occupy ಮಾಡುತ್ತೆ ಅಂತ ತಿಳ್ಕೊಂಡು, so now if you say join all these points, ಈ Cl ಅನ್ನ ಈ lone pairs ಗೆ ಕೂಡಿಸ್ಕೊಂಡು ಒಂದು solid geometry ರೆಡಿ ಮಾಡಿದ್ರೆ ಏನಾಗುತ್ತೆ, that will be the geometry. Keep this point in mind. So geometry ಅಂತ ಕೇಳಿದಾಗ you should consider the lone pairs also. So geometry, it will be octahedral, no doubt. But when it comes to the shape of the molecule, shape ಅಂದಾಗ reality, we need not consider these lone pairs. ಈ lone pairs ಇಲ್ಲ ಅಂತ ತಿಳ್ಕೊಂಡ್ರೆ just this species, this much if you consider, it will be square planar. Lone pairs, to avoid repulsion, they tend to occupy as far away as possible in space, so therefore they will be opposite to each other, and the remaining part of the molecule will be square planar. And now therefore the correct answer when it comes to geometry of this molecule, geometry, it is said to be octahedral, and shape of the molecule, it is square planar. Confuse ಮಾಡ್ಲಿಕ್ಕೆ ಏನೇನೋ ಆಪ್ಷನ್ಸ್ ಕೊಟ್ಟಿದ್ದಾರೆ, but here you can find the correct option. Octahedral is the geometry, and square planar is the shape of the molecule, right? So VSEPR, it will be very, very important. So therefore you need to work out more examples, and you need to practice, and then you can answer any questions related to VSEPR. Let's move on to the next question. Right. So the next question, it is to find out the acidic oxide from the following, right? So what you find is some oxides: calcium oxide, magnesium oxide, strontium oxide, and barium oxide. So among these, which is most acidic? That is the question. First point that you should know to answer this question is that all these are metallic oxides: calcium, magnesium, strontium, barium, group 2 elements, alkaline earth metals, so they are considered to be metallic. And metallic oxides, they are basic in nature. So strictly speaking, all these, they are basic oxides. But now the question is, among these basic oxides, which is most acidic? That is the thing that you need to find out, right? So now this point you can remember: metallic oxides, they are always basic, and non-metallic oxides, they are acidic. So this point you can just keep in mind. Now let's consider these metallic oxides itself. In these metallic oxides, which is most acidic? That we need to find out. For that, we need to know the metallic characters of this. And these are group 2 elements, and if they are arranged properly: beryllium, magnesium, calcium, and strontium. And we know that if you move down the group, metallic character, it increases, size increase agutte, tendency to lose the electron, it will increase, and metallic character, it will increase. Metallic oxides are basic antide, metallic character increase ಆಗ್ತಾ ಇದೆ ಅಂದ್ರೆ down the group, acidity of the oxide, it has to decrease, ರೈಟ್. ಮೆಟಾಲಿಕ್ ಕ್ಯಾರೆಕ್ಟರ್ ಇನ್ಕ್ರೀಸ್ ಆಗಿತ್ತು ಅಂತ ಹೇಳಂದ್ರೆ ಅವಾಗ ಬೇಸಿಕ್ ಕ್ಯಾರೆಕ್ಟರ್ ಜಾಸ್ತಿ ಆಗಿತ್ತು. ಮೆಟಾಲಿಕ್ ಕ್ಯಾರೆಕ್ಟರ್ ಡೌನ್ ದ ಗ್ರೂಪ್ ಇನ್ಕ್ರೀಸ್ ಆಗ್ತಾ ಇರೋದ್ರಿಂದ, ಐ ಮೀನ್ ಮೆಟಾಲಿಕ್ ಕ್ಯಾರೆಕ್ಟರ್ ಇಫ್ ಇಟ್ ಇಸ್ increasing, acidity of the oxides that has to decrease. Basic character ಜಾಸ್ತಿ ಆಗುತ್ತೆ ಅಥವಾ acidity of the oxide it has to decrease. So now from this logic you can say that so among these acidity ಹೀಗೆ decrease ಆಗ್ತಾ ಇದೆ ಅಂತ ಹೇಳಿದ್ರೆ this one beryllium it should produce most acidic oxide. So therefore beryllium oxide it should be the most acidic oxide among these, right? So ಅದೇನು acidic ಇರೋದಿಲ್ಲ, but comparatively ಹೇಳೋದಿತ್ತು ಅಂತ ಹೇಳಿದ್ರೆ beryllium oxide it can be said to be most acidic among this given. Let's move on to the next question. So this is based on the knowledge of redox titrations, and of course the concept of molarity and normality is also to be known to answer this question. So what they have given is they have given a reaction of iron 2 with the dichromate ion. Dichromate is oxidizing iron 2 plus ions to iron 3 plus ion, and the question is in connection with the molarity and normality of this dichromate species. Fine. So now in this case dichromate ion it is acting as oxidizing agent, and if you just observe how this dichromate species is changing, dichromate it is changing to chromium 3 plus ion. Cr2O7 dichromate ion it is changing to Cr3 plus species. So chromium it is in 6 plus oxidation state, and chromium it is changing to 3 plus oxidation state after the reaction. So now if you consider this Cr2O7 2 minus species, 6 ಇದು 3 ಆಗಿ ಕನ್ವರ್ಟ್ ಆಗ್ತಾ ಇದೆ, and 2 such 3 species are produced. So therefore from this oxidation state you can say that this chromium species, each chromium species it is accepting 3 electrons in the process, and 2 Cr ಇರೋದ್ರಿಂದ totally Cr2O7 2 minus it is said to accept 6 electrons together. And for oxidizing agent if you have this knowledge of ಎಷ್ಟು electrons ಅನ್ನ accept ಮಾಡ್ತಾ ಇದೆ ಅನ್ನೋದು ಗೊತ್ತಾದ್ರೆ, from that what is the relationship between equivalent weight and molecular weight that can be found out, right? And based on this knowledge we can say that 1 mole of potassium dichromate that will be equal to 6 equivalents of Cr2O7 2 minus, because it is accepting 6 electrons. 1 mole tagondre it is as good as taking 6 reactive entities, as it is accepting 6 electrons in total. So therefore 1 mole of Cr2O7 2 minus it will be equal to 6 equivalents of Cr2O7 2 minus. So if we know this relationship, and if we further know what is molarity and what is normality, molarity it is nothing but number of moles of solute present in 1 liter of solution. ಎಷ್ಟು moles ಇದೆ in 1 liter, that is called as molarity. Normality is number of equivalents they are present in 1 liter of the solution. Because 1 mole that is equal to 6 equivalent, so ನೀವು 1 molar solution ತಗೊಂಡ್ರಿ ಅಂತ ಹೇಳಿದ್ರೆ 1 molar ಅಲ್ಲಿ it is obvious that you will be having 6 equivalents. 6 equivalents ಇದೆ ಅಂತ ಹೇಳಿದ್ರೆ it will be equal to 6 normal. So therefore ultimate conclusion is that 1 molar solution that should be equal to 6 normal solution. If you know the fact, straight away it can be answered. Otherwise, logically it has to be concluded, right? Let's move on to the next question. Right. So the next question, again, very important one, because again from this fact you can expect questions in any of the competitive examinations. It is based on valence bond theory of coordination complexes, right? So now what they have asked is the complex which is paramagnetic. That is the question, which means like among the 4, 3 should be diamagnetic and only 1 should be paramagnetic. So this can be either answered with the help of valence bond theory, or even you can go for crystal field theory. So let's try to answer this question on the basis of valence bond theory. Of course, whatever logic I have extended to this complex, of course this happens to be the answer that is to be applied to others, and you should make yourself, you should convince yourself that in all other cases you will not find any unpaired electrons. Only in this case FeCN6 3 minus option you can find unpaired electrons. That you should make sure, right? So if you consider the species FeCN6 3 minus, first you need to work out the oxidation state of iron. It happens to be 3. Fe it is in 3 plus oxidation state. So by taking X, by this time you should know how to calculate the oxidation state straight away, right? So like 3 minus charge barabeku, cyanide 6 minus, then obviously Fe it has to be in 3 plus state. So Fe electronic configuration, if I write it in ground state, you should know this 3d6 and 4s2. Of course 4p orbitals they will be empty, so 3d6 4s2 that will be the electronic configuration of iron in ground state. Now Fe plus 3 ಹೋಗಬೇಕು ಅಂದ್ರೆ the 2 electrons from 4s we have removed, and this 1 electron that has been removed, and now in Fe plus 3 state it will become 3d5. Now under the influence of 6 cyanide ligands, you must be knowing cyanides cyanide ligands, they are considered as strong field ligands. On that basis, we can go for pairing up of electrons, right? And if you go for pairing up of electrons, so 5 electrons are there and those will pair up like this. 2 will be here and 2 more will be here. 1 electron, it will be unpaired and it will be left here. And these 2 orbitals, they will be made empty, and now these 2 d orbitals, this s orbital and these 3 p orbitals, they will combine together to produce d2sp3 hybrid orbitals. And in those d2sp3 hybrid orbitals, you can expect electrons from cyanide. So cyanide, it will be donating electrons, and those electrons you can put it here, right? And 6 pairs of electrons, you can just fill them here. So now if you look at the overall situation, you can find one unpaired electron, and if there is one unpaired electron ಇದೆ ಅಂದ್ರೆ obviously you can call it as paramagnetic species, right? Whereas ide logic anna, or like valence bond approach, if it is applied to all other species A, B, as well as this is 3 minus, so A, B and D, you should find no unpaired electrons will be left over. Only in C you are having one electron, so therefore option C, this should be the correct answer. FeCN6 3 minus, that will be the correct answer for this question. Moving on to the next question. Next question, it is very simple one. It is just based on the formulation of silicates, right? So different types of silicates are there, and if you know all the silicates and their formulae, definitely it will be good. So this time they have simply asked ortho and pyro. So next time they can move on to the next type of silicates, which are little complex. But ortho and pyro, if you consider, they are straight away. So like here, ortho ಬಗ್ಗೆ ತಲೆ ಕೆಡಿಸ್ಕೊಳ್ಳೋ ಅವಶ್ಯಕತೆನೇ ಇಲ್ಲ, ಯಾಕಂದ್ರೆ in 3 of the options you can find that it is SiO4 4 minus itself. Usually none of the options, in maximum cases, the answer irodilla. So orthosilicate, it has to be SiO4 4 minus, right? And yes, it is correct that orthosilicate, it is SiO4 4 minus. You can find the structure here. Silicon, it will be having tetrahedral environment around it, and it will be linked to 4 oxygen atom. Each oxygen atom, it will be having O minus, 1 minus charge, and that will be your simple silicate, or which is known as orthosilicate. So this is actually your orthosilicate, right? So when 2 orthosilicate units join together with the help of 1 oxygen atom, that will form pyro-silicate. They have represented it here. It is pyro-silicate. So 2 such units, they have joined together with the help of 1 oxygen. So when they join together with the help of 1 oxygen atom, then minus charge will not be there over this oxygen atom. So this oxygen atom, it is linked to silicon, this is linked to silicon, and each silicon, it will be left attached to 3 more oxygen atoms with minus charge. One you can find here, one you can find here, one they have shown as so in the representation hage ant helidre, in case of silicates, if you find it this way, so this one, it is actually silicon atom. So they have shown here, ಸ್ವಲ್ಪ ಕನ್ಫ್ಯೂಸಿಂಗ್ ಇದೆ, ಅದಕ್ಕೆ ಕ್ಲಿಯರ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ. ಆ ಡಾಟ್ ಅನ್ನ ಜಸ್ಟ್ ಸಿಲಿಕಾನ್ ಅಂತ ತಗೊಳ್ಬಹುದು, ಅಂಡ್ ಅದಕ್ಕೆ ಸರ್ಕಲ್ ಏನ್ ಹಾಕಿರ್ತಾರಲ್ಲ, ಸೊ ದಟ್ ಕ್ಯಾನ್ ಬಿ ಕನ್ಸಿಡರ್ಡ್ as oxygen atom. So therefore here what you can find is that one silicon atom, above that there is one oxygen atom with minus charge. So like 1 O minus, second O minus, third O minus. Here also same thing, totally 6 oxygen atoms with minus charge and 1 neutral oxygen atom, 7 oxygen atoms and 6 minus charge and 2 silicon atoms. So therefore formula of this, it should be, this is no doubt SiO4 4 minus, and this one, it should be Si2O7 2 minus, and Si2O7 2 minus you can search for Si2O7 2 minus, option B. SiO4 4 minus as well as Si2O7 7 minus, that will be the correct answer for this question. Next question, it is based on nuclear chemistry, and related to this also, definitely you can expect questions. So this question paper is so that typically when the chemistry competitive exams thalli ಯಾವ sections in the question barutte, most of the typical questions, they have been covered here, and questions are good questions. Just by hearting or just by knowing the information you cannot answer. You need to apply the knowledge that you have, then only you can find out the answer. So let's move on to this question. So what they say is that astatine isotope, it is produced by bombarding bismuth 209 with alpha particle. So in this reaction, along with this astatine, what else is produced, that they have asked, right? So whatever information they have given, just it has been represented. Bismuth 83209, it is bombarded with alpha. Very important thing, alpha, you should know that its Z, it will be 2, and its A, it will be 4. It is like helium nucleus. So alpha particle, ಅದರ ಮೇಲೆ mass number ಏನಿರುತ್ತೆ and ಅದರದ್ದು ನಿಮಗೆ Z ಏನಿರುತ್ತೆ ಅದು ಗೊತ್ತಿರಬೇಕು, otherwise you cannot answer this. So now you can find here what you can find here is that bismuth, when it is bombarded with alpha, astatine is produced, and if you just go for the sum of Z, this is called as Z. So Z85, right? So mattenu nimge illi Z athwa protons extra uludilla. 209 plus 4 if you consider, it will be 213, but astatine just 211 ಆಗಿದೆ. ಇನ್ನೂ ಎರಡು ನಿಮಗೆ ನ್ಯೂಟ್ರಾನ್ಸ್ ಉಳ್ಕೊಂಡಿದೆ. ನ್ಯೂಟ್ರಾನ್ಸ್ ಉಳ್ಕೊಂಡಿದೆ ಅಂತ ಹೇಗೆ ಹೇಳ್ತಾ ಇದ್ದೇನೆ ಅಂತ ಹೇಳಿದ್ರೆ, ಚಾರ್ಜ್ ಪಾರ್ಟಿಕಲ್ ಏನೂ ಇಲ್ಲ ಇಲ್ಲಿ. 83 ಇದು ಪ್ರೋಟಾನ್ಸ್ ಅಂತ ತಗೊಂಡ್ರೆ, so 83 plus 2 85 protons, they have been covered by astatine, so no protons are left. But what we are left with is some mass. 209 plus 4 ಅಂದ್ರೆ 213 ಆಗಬೇಕಾಗಿತ್ತು, 211 ಆಗಿದೆ. ಸೊ ನಿಮಗೆ 2 ಯೂನಿಟ್ ಮಾಸ್ ಬರಬೇಕು, ಚಾರ್ಜ್ ಪಾರ್ಟಿಕಲ್ ಇಲ್ಲ. ಸೊ ದಟ್ ಮೀನ್ಸ್ ಯು ಶುಡ್ ಹ್ಯಾವ್ ನ್ಯೂಟ್ರಾನ್ಸ್ ಇನ್ ದಿಸ್ ಕೇಸ್. ವಿತ್ ಪ್ರಾಕ್ಟೀಸ್ ಯು ಕ್ಯಾನ್ ಡೂ ಆಲ್ ದೀಸ್ ಥಿಂಗ್ಸ್. Neutron, it will be having 0 charge and 1 mass, and 2 mass unit difference irodrinda 2 neutrons it will be ejected in this process, and therefore bismuth, when it is bombarded with alpha particles, astatine, along with that 2 neutrons will be produced, and answer it should be this, B, neutrons, right? So similar other questions related to this in different way definitely can be asked, and you need to practice this kind of reactions. Itaradondist reactions alli hage nimge overall mass and atomic number it is conserved, number of protons and number of neutrons conserve ಆಗುತ್ತೆ ಅನ್ನೋದನ್ನ practice ಮಾಡಿದ್ರೆ easily you can answer questions related to this kind. 10th question, very straight away, right? It's just simple percentage calculation. What they have said is that they have taken 0.5 grams of hematite ore, right? And in that hematite ore, they have given you that experimentally it is found to be 0.3 to 5 grams of iron 3 oxide. Iron 3 oxide ಅಂತ ಹೇಳಿದ್ರೆ it is nothing but Fe2O3 itself, right? So ಅದನ್ನೇ iron 3 oxide ಅಂತ ಬರೆದಿದ್ದಾರೆ. So it's actually Fe2O3, right? So now what they ask is that what is the percentage of Fe2O3? Straight away this question it can be done. Percentage of Fe2O3, that should be is equal to amount of Fe2O3 divided by total amount of ore into 100, right? You can just go for simplification. Mathematically simplification antadenu kashta illa. See 0.5 grams ಗೆ 0.325 ಇದೆ ಅಂದ್ರೆ for 1 gram it should be double, right? It should be 0.65 gram. 0.325 is the double ತಗೊಂಡ್ರೆ it will be 0.65 grams, that will be in 1 gram into 100 ಮಾಡಿದ್ರೆ it will come to 65. So therefore 65%. So ಇಲ್ಲಿ confuse ಆಗಲಿಕ್ಕೆ 6.5 0.65 ಎಲ್ಲ ಕೊಟ್ಟಿದ್ದಾರೆ. You should be very careful. It is 65% because they have asked the thing in percentage ಅಂತ ಕೇಳಿರೋದ್ರಿಂದ the answer it should be this option D, 65% straight away. That should be the answer for this. Right, next question, it is also a damn simple question, but the way in which the question it has been given, it looks it's little difficult. Enu illa, straight away kelidare. So some salt mixtures they have given, not single salt. KCl and MgNO3 twice, potassium chloride, magnesium nitrate, manganese chloride and potassium sulfate, barium chloride, potassium chloride, and finally ammonium carbonate and ammonium chloride. These salts an ಕೊಟ್ಟಿದ್ದಾರೆ. So they have added dilute H2SO4, and ಯಾವ ಕೇಸಲ್ಲಿ precipitation ಬರುತ್ತೆ ಅಂತ ಕೇಳಿದ್ದಾರೆ. You should know the fact that barium sulfate precipitates very easily. So when you do inorganic analysis, so ions, cations, acid radicals, basic radicals find out ಮಾಡಬೇಕಾದ್ರೆ you will be knowing this fact that barium sulfate it precipitates very easily. All other sulfates they will be having sufficient solubility. Of course ಎಲ್ಲಾ ಕೇಸಲ್ಲಿ sulfates formation ಆಗತ್ತೆ, but ಎಲ್ಲ sulfates ಉಳಿದಿದ್ದ ಎಲ್ಲ sulfates soluble state ಅಲ್ಲಿ ಇರುತ್ತೆ. Only barium sulfate it will precipitate out easily because of its very less solubility in water. So therefore, so among these, when you consider this mixture, barium chloride and potassium chloride mixture, barium chloride it will form barium sulfate, that will precipitate. This potassium chloride it will form potassium sulfate it will be in soluble state. So therefore option C, that should be the correct answer for this question. Barium chloride plus potassium chloride. Main andre barium sulfate it precipitates. That is the logic. 12th question. This is also very straight away question. So based on the construction of periodic table, Mendeleev, when he had prepared his periodic table, so he had predicted the existence of unknown element, and he has even left some space in his periodic table. So and that was named as eka-aluminum. Eka-aluminum ಅಂತ ನೇಮ್ ಮಾಡಿದ್ದ. He had predicted that property of that element it will be similar to that of aluminium, and ಅದು aluminum ಕೆಳಗೆ ಬರುತ್ತೆ in periodic table. That position he had predicted. So which is that element ಅಂತ ಕೇಳಿದ್ದಾರೆ. So if you just know the fact that the element which he had predicted it was aluminum kedak barbeku annod logic gottidre easily you can answer this question. Eka-aluminum was the name given by Mendeleev to the undiscovered element which now exists by the name gallium. Aluminum keda gallium barutte, and they are group 13 elements. You should know group 13 elements. Group 13 elements they have been given here: barium, boron, aluminium, gallium, indium, thallium, and nihonium. Usually ಇದನ್ನ ನೆನಪಿಟ್ಕೊಂಡಿರೋದಿಲ್ಲ, but now even this element has been named. Thallium ಕೆಳಗೆ ಬರುವಂತದ್ದು, it's nihonium, right? So easily you can remember this with a mnemonic. Say Bal Gangadhar India Tilak. Bal Gangadhar India Tilak ಅಂತ ನೆನಪಿಟ್ಕೊಂಡ್ರೆ group 13 elements you can remember them very easily. So B, Al, Ga, En, In, and Tl. So the element which lies below aluminum, it should be gallium, and that's how the answer, it should be gallium for this option C, right? So that is the answer. Let's move on to the next question. Again, you can expect questions related to oxidation state. All these are very, very basic knowledge, very elementary knowledge. You should know all these things, right? So in this question, they have given you 3 species. Now you cannot expect just one species and calculation of oxidation state, right? So exams ಈ ವರ್ಷದಿಂದ ವರ್ಷಕ್ಕೆ ಟಫ್ ಆಕೋತಾ ಹೋಗುತ್ತೆ. So therefore 3 species they have given, and for all they have asked oxidation states. So one thing, if you know, ಇಲ್ಲಿ ಎರಡು ಆಪ್ಷನ್ಸ್ ಅನ್ನು ಈಸಿಲಿ ಎಲಿಮಿನೇಟ್ ಮಾಡ್ಲಿಕ್ಕೆ ಬರುತ್ತೆ. ಸೊ ಸಲ್ಫರ್ S8 ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ. ಸೊ ದಟ್ ಮೀನ್ಸ್ ಸಲ್ಫರ್ ಇಟ್ ಇಸ್ ಇನ್ ಎಲಿಮೆಂಟಲ್ ಸ್ಟೇಟ್. ಸೊ ಎಲಿಮೆಂಟಲ್ ಸ್ಟೇಟ್ ದಲ್ಲಿ ಯಾವುದೇ ಎಲಿಮೆಂಟ್ ಇದ್ರೂ ಅದರ ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟ್ 0 ಆಗುತ್ತೆ. If you know this fact, just based on that fact, you can eliminate this option B as well as option C. ಯಾಕಂದ್ರೆ ಇಲ್ಲಿ +8 and 8 ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ, right? But any element which exists in elemental state, ಬೇರೆ ಯಾವುದು atom ಜೊತೆ ಕಂಬೈನ್ ಆಗಿಲ್ಲ ಅಂದ್ರೆ ಅದರ ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟ್ 0 ಇರುತ್ತೆ. ಸೊ therefore straight away ನೀವು ಎರಡು ಆಪ್ಷನ್ಸ್ ಎಲಿಮಿನೇಟ್ ಮಾಡಬಹುದು. ಸೊ ಫಾರ್ ಉಳಿದಿದ್ದ ಎರಡು ಆಪ್ಷನ್ ಅಲ್ಲಿ ಯಾವುದು ಅಂತ ಫೈಂಡ್ ಔಟ್ ಮಾಡಬೇಕಂದ್ರೆ you should find out the oxidation state of sulfur in this species as well as in this associated species. Let me do that very quickly. So first, if I consider this H2SO3, let's say I take this sulfur oxidation state as X, right? So then what I do is ಉಳಿದಿದ್ದು ಎಲ್ಲದು ಸ್ಪೀಶೀಸ್ ಏನಿದೆ ಅದಕ್ಕೆ ಕಾಮನ್ ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟ್ ಏನಿರುತ್ತೆ ಅದನ್ನ ಹಾಕಿ, so I equate everything to 0 and I'll try to find out the value of X. So that's the method that we do. So 2 hydrogens, and hydrogen it will be always in +1 oxidation state. So plus X, sulfur ಗೊತ್ತಿಲ್ಲ, plus oxygen 3 atoms are present, and oxygen oxide form ದಲ್ಲಿ ಇದ್ರೆ you should be very careful. Sometimes peroxide ಎಲ್ಲ ಕೊಟ್ರೆ -2 ಆಗಲ್ಲ, -1 ಆಗುತ್ತೆ. In this case it is in oxide form, so therefore -2. So if I go for simplification, it's very simple. It will be like 2 plus X. Of course this is to be equated to 0, right? And this will be -6. That has to be equal to 0. So now if you simplify this for X, right? So -6 plus 2, it will be -4. -4 ikkade bantu andre it will be +4. So therefore option A and D, in both the cases you can find +4. So therefore based on this you cannot decide the answer. Let's move on to this. So here let me take the oxidation state of sulfur as Y, and one oxygen atom, and its oxidation state it will be -2 oxide formula ide illi, and the next plus 2 chlorine atoms, and each of them it will be in -1, so overall equal to 0. So now if you go for simplification, so this will be like Y -2, and then here again -2, right? That will be is equal to 0. So in this case also -2 -2 it will be -4. -4 if I take it to the other side it will be +4. So Y again in this case also oxidation state it is +4 itself. So therefore the correct answer for this it should be this option D, and it is +4, 0 and +4, right? So here they have given -2, which is wrong. So therefore correct answer for this is option D. Next question. So some facts they have given, and regarding this statement, which is the correct fact that has to be identified. Xenon forms compounds with fluorine and oxygen. You might have studied interhalogen compounds and compounds of noble gases and all. So compounds of noble gases al baratte. Xenon, it is the most common noble gas which can form compounds with fluorine as well as oxygen. So idakke reason enu anta kelidare. So if you look at the options carefully, option D and option B as well as option D, these can be eliminated quite easily. Option B and option D, it can be eliminated quite easily if you know the fact that xenon it has this electronic configuration 5s2 5p6, which is considered to be stable electronic configuration, right? So if you just know this fact, on this basis xenon has more affinity for electrons. It is wrong because it has, say, stable configuration, so therefore it has very less affinity, so therefore this statement is wrong. And xenon has vacant p orbitals, no, p6 fill agide, so therefore this is also wrong. These two statements you can just remove. Right, now we are left with A and C. Xenon has lower ionization potential and O and F are electronegative. Xenon has higher ionization potential, O and F are electronegative. This statement is common. Right, so now you should decide between these two. Right, so now you should be a bit careful. It is everything comparative. Xenon has lower ionization potential, xenon has higher ionization potential and kotidevi. So in general speaking, all the noble gases, they will be having higher ionization potentials itself. It will not be that easy to remove the electrons from this stable electronic configuration. But among the halogens compared to helium, neon, xenon kinta mere iruvanta halogens, noble gas compare madidre, xenon it has less ionization potential, and that's how oxygen and fluorine relatively they can take off electrons from xenon quite easily, and therefore we should go with comparatively xenon it has less ionization potential, and option A should be made as the correct answer, right? So we do comparative with that. For other halogens, helium, neons, they will not form the halogen compounds that easily as compared to that of xenon. On that basis, A should be the correct answer for this. Right, so next question, again it is related to molecular orbital theory, and definitely you can expect questions related to molecular orbital energy level diagram. One question definitely you can expect in any of the competitive exams, so you should be well versed with the construction of molecular orbital energy level diagrams from hydrogen to say fluorine, right? So this is in connection with C2. So readily I have given you the molecular orbital energy level diagram for C2 species. And now if you just go with this diagram, you can clearly find that all the electrons here, they are filled. 1s, it combines with 1s to produce sigma 1s, sigma star 1s, that is filled. So here it should have been 2s, right? So this should be 2s, and again this is 2s, and 2s when they combine together, they will produce again sigma 2s, sigma star 2s. 4 electrons, they will be filled here in these molecular orbitals. Now when you consider this 2p and 2p will combine to produce this kind of molecular orbitals. Idu nitrogen kinta kedagirodrinda, you should know that this pi bonding molecular orbitals, they will be coming down, right? Oxygen adre idu ee sigma kedag bandu pi male hogtade. All those facts you should remember. Now if you fill the electrons, 4 electrons from 2p, 2 from here and 2 from here, they will be occupied here, and what you can find is that totally no unpaired electrons, they are left over. That is one fact. No unpaired electron left over under the species, it should be diamagnetic, right? So illi diamagnetic ide, innondu diatomic ant kottidare. Diatomic fine. So just to confuse diamagnetic and diatomic, idanna use madidare diatomic, but diamagnetic, that should be the correct answer. Ishtu gottittu andrunu without calculation of bond order you can go with this, but if you know how to calculate the bond order, it can be calculated by counting total number of bonding and anti-bonding electrons. Bonding electrons, if I count 2 plus 2 plus 2 plus 2, so totally it will be 8, and anti-bonding electrons here blue dalliruvantadu anti-bonding 4, 8 minus 4 by 2, it will be coming to 2. So therefore bond order it will be 2, and because no unpaired electrons are left, so it should be diamagnetic. Option D should be the correct answer for this. The next question, right? So this is with respect to sodium chloride, some statements they have given. Among this, which are correct statements that they have asked? So itaradiddaga question, it will be really a little difficult. If you know all the facts, then only you can answer the questions correctly. Otherwise there are chances that even ಒಂದು ಅಥವಾ ಎರಡು ಕರೆಕ್ಟ್ ಇದ್ದಿದ್ದು ಐಡೆಂಟಿಫೈ ಮಾಡಿದ್ರಿ, ಒಂದು ಯಾವುದು ಮಿಸ್ ಮಾಡಿದ್ರಿ ಅಂದ್ರೆ may go wrong with this. So you should know everything properly, then only you can answer this. So now with respect to sodium chloride, both sodium and chloride ions adopt inert gas configuration. Yes, sodium chloride formation alli sodium, when it forms Na plus, it will become 2s2 2p6, that will be the noble gas configuration, and Cl, it will be forming Cl minus to form 3s2 3p6 configuration. Both these are noble gas configurations. Yav noble gases, you just try to find it out, and therefore this first statement, yes, it is correct statement. Both sodium and chloride adopts inert gas configuration, it is correct. So second one, the conduction band is full, right? So in fact this is also correct. So new band theory hodaga, what it says is that you should have valence band and you should have conduction band. Valence band it should be filled and conduction band it should be empty. Then if this energy gap it is less, band gap anta kariteve, if this energy gap it is less, then electrons they will move from valence band to conduction band, and that will be giving you electrical conductivity. But because here in this case conduction band is full, solid sodium chloride if you take, it will be a bad conductor, or it will be insulator of electricity. So therefore conduction band it will be filled. That is correct, right? So this statement should be correct. Third statement, conduction band empty ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ, filled ಇದೆ ಅಂತ ಹೇಳಿದ್ರೆ empty ಇರ್ಲಿಕ್ಕೆ ಚಾನ್ಸ್ ಇಲ್ಲ. ಇವೆರಡರಲ್ಲಿ ಯಾವ್ದಾದ್ರು ಒಂದೇ ಸ್ಟೇಟ್ಮೆಂಟ್ ಕರೆಕ್ಟ್ ಆಗಬೇಕು. ಸೊ ಆನ್ ದಟ್ ಬೇಸಿಸ್ ಡೆಫಿನೆಟ್ಲಿ ಐ ಕ್ಯಾನ್ ಎಲಿಮಿನೇಟ್ ಆಪ್ಷನ್ 3. ಲಾಸ್ಟ್ ಒನ್, ಇಟ್ ಕಂಡಕ್ಟ್ಸ್ ಇನ್ ಮೋಲ್ಟನ್ ಸ್ಟೇಟ್. ಸಾಲಿಡ್ ಸ್ಟೇಟ್ ದಲ್ಲಿ ಇಟ್ ಇಸ್ ಇನ್ಸುಲೇಟರ್, ಬಟ್ ಎಸ್ ಇಟ್ ಕಂಡಕ್ಟ್ಸ್ ಎಲೆಕ್ಟ್ರಿಸಿಟಿ ಇನ್ ಮೋಲ್ಟನ್ ಸ್ಟೇಟ್. ಸೊ ಇನ್ ಮೋಲ್ಟನ್ ಸ್ಟೇಟ್ ions formation ಆಗುತ್ತೆ, Na plus and Cl minus. Those ions they move between the electrodes, and that can bring or that can give electrical conductivity to molten sodium chloride. Therefore this statement is also correct. Therefore only 3 is wrong, all other statements they are correct. So therefore this option 1, 2, 4 are correct. That will be the correct answer for this. Last question from inorganic section. The d orbitals involved in the hybridization of copper in representing the square planar geometry, again related to valence bond theory of coordination complexes. So in the next slide, so different hybridizations possible and yav d orbitals use agutte adak examples, all those details I will provide. So now if I give the information, important information, square planar complex if you consider, always it will be dsp2 hybridization. And now very important, ಈ dsp2 hybridization ಅಲ್ಲಿ ಇದು d orbital ಯಾವುದು and ಇವು ಎರಡು p orbitals ಯಾವುದು, that you should know, right? Of course ನಾವು ಇಲ್ಲಿ ಕೇಳಿರೋದು ನಿಮಗೆ d orbital ಯಾವುದು ಅಷ್ಟೇ ಕೇಳಿದ್ದಾರೆ, but if you know the extra information definitely it will be useful. So always remember square planar ಅಂತ ಹೇಳಂದ್ರೆ the bonding it will happen in x and y axis. xy axis ದಲ್ಲಿ ಯಾವ orbitals orient ಆಗಿರುತ್ತೆ ಆ ಎಲ್ಲ orbitals bonding ಅಲ್ಲಿ participate ಮಾಡುತ್ತೆ. So the d orbital which is having lobes in x and y direction, it is dx square minus y square. You should know this. dxy ಅದು x and y along the axis ಇರೋದಿಲ್ಲ, in between the axis ಇರುತ್ತೆ dxy ದಲ್ಲಿ, whereas dx square minus y square, if you remember the things, in dx square minus y square along x as well as y axis you can find the lobes. Therefore dx square minus y square, and px and py it will also be having lobes in x and y direction. So therefore dsp2 hybridization, d orbital involved dx square minus y square, p orbitals involved px and py. Similarly for other some common geometries I have given. Square pyramidal idre dsp3 hybridization, trigonal bipyramidal idre dsp3 hybridization itself. Hybridization same for square pyramidal and trigonal bipyramidal pentacoordinated complexes, but main difference ಏನು ಬರುತ್ತೆ ಅಂತ ಹೇಳಿದ್ರೆ, here in square pyramidal it will be d orbital dx square minus y square, major participation ಆಗೋದು dx square minus y square orbital, and in the case of trigonal bipyramidal major orbital which will be participating in hybridization is dz square, right? Note this difference. Octahedral you might be knowing d2sp3 if it is inner orbital complex, sp3 d2 ಅಂತ ಕರಿತೇವೆ outer orbital complex, but in both the cases d orbitals involved are dz square as well as dx square minus y square. Both these will be participating, right? So as I told you, extra information I have provided with examples. Just go through this and you can note down hybridization and other details, right? And yeah, you can pause and you can work out more on this valence bond theory of coordination complexes. That will also be one of the very important aspect from where we can expect question, right? So with that it completes 17 questions from inorganic chemistry from previous M.Sc entrance examination of Karnataka University 2021 examination. So thank you for watching this video. If you are new to this channel, please subscribe to this channel, and for next video notification bekadre you can just press the bell icon, and please let me know in the comment section if you want me to do other videos, organic and physical videos beku andre, please you can just let me know that in comment box. And I thank Mrs. Divya Hegde and Valerie D'Souza for providing me these questions. Thank you.